Hey, Rice here. Today we're going to take a look at how to make a graph like this one from your Rollercoaster lab data. And from that point, we're going to take a look and see how energy plays out over the course of the lab. First thing you'll need is to have a table filled out like this, and we'll go over how to build that table real quick. And then we'll look at how to build the graph. The graph is corresponding to labs that look like this, where there's a roller coaster track and you roll a marble down the track and record the times. And we're specifically, well, there's a little bit of this. We're specifically going to take a look at these positions along the track. So when you see the letters A, B, C, D, E, F, G, and H, this is what they're referring to, just so that you can see that one more time. And then we'll come back to our Google Sheet so that we can see what's going on here. This is actually a more complicated graph than you need to have. It's got friction loss and rolling kinetic in there, which I encourage you to pause, take a look at this, see what that's doing for the overall energy for the track. But for you, we'll just be graphing potential and kinetic. So take this and get it out of the way. And then we're going to take a look at this table. So up here at the top, we've got the mass and the diameter of the ball. And I just wrote them in up here in this B column so that I could reference back to them. I even put in units so that it was clear what they were referring to. And so these I measured in the lab, and I got the mass and the diameter of the ball that I'm rolling down the track. These are the heights and the photogate times that I've measured directly, and if I click on any one of these, you'll see that it's just a number that's typed in there. Those I typed in all of them just as you see them. But then things like velocity I calculated. So this one had this expression, which took the number up here, and always that number, the dollar signs means that it's going to always look at that cell, and I divided by the cell to the left. So that gives me the velocity. It's just the ball diameter divided by the photogate time. And you can do that manually, or you can do it in the spreadsheet, it doesn't matter. And so you can see that it does that for every one of these all the way down. Then I calculated the kinetic energy using the kinetic energy equation, which is 1/2 mv squared. So a half times the mass, which is B1, and so it's locked into B1, times the velocity, which is this right here, squared. So 1/2 mv squared to get my kinetic, and then my potential is mgh, so always the mass, times 9.8, which is little g, and then the height is listed right here. So those things multiplied together. These are more advanced: rolling kinetic, friction loss, and total energy. You don't need to have those. If you wanted to see just real quick, here's the equation. This is by far the most complicated one. Next up is the friction loss. I just took that and actually subtracted to get it from the total energy. The total energy is just my starting potential energy. That's the most energy I would have in the whole thing, and everything is going to lose from there based on friction. So these are all just this first potential energy amount, and then these are subtracted, this minus these other three. Now, how do we make the graph? To make a graph, what I really want to make is kinetic and potential energy. So what I'm going to do is select these and say insert a chart. And I want to be very specific about what kind of chart to make. I want this stacked column chart, but not the 100% stacked column. I want this stacked column. So now I do this. You can see it tells me that I have potential and kinetic. I've highlighted those when I selected my series. And then my x-axis is also important. I want to get my positions as my x-axis. So you can see now that it's listed as A, B, C, D, E, F, G, and H across the bottom. I've got my graph here. All I need to do is make some of my titles. So horizontal axis title, this would be roller coaster positions. And then I can change my vertical axis title, energy in joules. And I can put in my chart title, energy over a roller coaster. Maybe I should capitalize a little bit there. But this is the quick version of that graph that you need to make. Now if you look, you can compare it to the one that I had up here earlier. And the big difference is that I've got, in this one, more types of energy. So one of the problems with this lab for you is that you're going to see that not all of the energy is accounted for. So you've got this stuff up here that doesn't show up, that over here I put into my graph so that we could have a better picture of what's going on. So you may want to compare these two images just to see what's similar and what's different, but it's not required for you to have those. I just wanted to show you what that would look like. Okay, that's it. Good luck.